Hello, so many people. Thank you. So yeah, we're here to talk about the Sherman project, which is a short animation that my team created at Unity shortly after the Disney Baymax project that was actually just playing there. So it was the same core team that worked on the Baymax project, and we wanted to extend it and see if we could push some of the technology and techniques further. So before we get started, I'm going to play the Sherman short, and we'll see if that works. Go. Thank you. Some key stats here. So Sherman was done end-to-end inside of Unity. We did not do storyboarding. We went straight into 3D from the idea that we had. This is the same technique we used for the Disney project, where we didn't do storyboards. All of the idea was created in Unity and figured out inside Unity. We had a very small core team. There's basically one animator. We had another, the cinematic director did some final touch-up animation, one modeler, a single graphics engineer, and then a producer. So the technology, it's the usual suspects for technology. So Timeline is our non-linear editor, Cinemachine, the HD render pipeline, and we did concept to final frames with Unity 2018.4. Obviously, the standout sort of graphics feature is the fur implementation, which I'll talk a little bit more about. So obviously, everything we do is built on what was done before. The very first sort of big short like this was done by our Unity Japan team, where they did a project called The Gift, and they had a sort of a very, very early implementation of fur. And we built on top of that to create the version that we have. So from the original idea, we blocked out in Unity. The animator created this by himself in, I think, a day or so. We figured out what the story was, what exactly was the idea we were trying to produce. And then we did all the camera work with Cinemachine, our procedural camera technology. So one important thing when you're moving to real time is how you do your look dev. This is probably one of the biggest changes, is how do you make something achieve the visual style. So first, we set our bar very high. We wanted to be as good as DreamWorks or the Disneyland commercial. We'll see if we got that high, but well, that was the goal. We started out, most of the assets inside of the project, the gnome, the sprinkler, just use the built-in HD render pipeline material. It's just the HD lit. We borrowed some assets in the background, the big trees from the Book of the Dead, and then slightly modified them to fit the film. One big difference when we're working on animation or shorts is instead of in games, you're always optimizing for performance. You're trying to get 60 frames a second. When we're working on animations, we're doing the opposite. We're optimizing for quality, not performance. However, you do want to maintain the iteration speed. You want to be able to work on and change things quickly. So we developed a very simple detail system to allow us to go from fast iterate and then crank everything to 11 for high detail. For things like color grading, we had, and your overall lighting, we had basically a global or set profile. And then with Cinemachine, you can get in and get very detailed on per shot, depth of field, exposure, vignette, and so on. And Cinemachine actually has a storyboard feature that we could actually load in reference images or storyboards, and you can actually sort of side by side see both views. So again, we had a single modeler on the project. So this had impact on how many assets we could build, how much time we could spend on them. But again, most of the assets are actually just the built-in HD lit shader. There are a few things that we used our shader graph, which is our node-based material editor, for which allows the artist to create custom materials or custom look for their own. For example, for the hose when it explodes, there was a certain look that the artist wanted to do. So this allows artists to create their materials without needing a programmer or an engineer. For camera layout, we used Cinemachine. If you are not familiar with Cinemachine, it is a procedural camera system that allows, the cameras know what they are trying to shoot. So the camera knows it's targeting the raccoon. So anywhere we move the camera, it's always going to remain targeted on the raccoon. This is very important to allow you to iterate quickly. You can change ideas, change how fast animation goes, change where cameras are, and the cameras are always going to be valid. Normally, you would have camera animation and character animation separate, and they don't know about each other. So this gives you the ability to connect the two, which is very important. Obviously, animators want to know what they're animating against, so you need to be able to take that information back out to the animation tool, in this case, Maya. So we would use our FBX exporter to export the camera so the animator knows what final cameras he's working on. So Timeline is our nonlinear editor. So this allows you to work similar to an editing tool like Adobe Premiere or Resolve. But you can see there are camera clips, which is the red track, but then you can still keyframe things. So that's what all of these tracks here are. So you can keyframe things like depth of field or position or animation. So you don't it isn't just procedural. You have the procedural, and then you can customize on top. And this is very important. Directors and your cinematographer wants that very, very precise control. For animation, and during the Baymax project, we used the FBX format. We wanted to explore some alternatives. And as of 2018, or I think it was 2018-3, Alembic became a officially supported format, which is very common in animation production. So we used Alembic for the file format for this. At the time, there was some limitations with FBX that are no longer the case in the new 2019 releases. But the big one is Alembic allows you to do advanced deformers and skinning techniques. For example, squash and stretch. So this one is very important where it's not something that's normally easily done in a real-time engine, but Alembic allowed us to do this kind of thing, where you can really manipulate the character's rig, which is what the animator wanted. Alembic has its own challenges. It's very large format. Basically, every frame of animation has the entire model, basically. But you can see here the entire project was 12 gigabytes. Just the animation data was 7 of that. So it's a very heavy format, which poses its own challenges. Alembic also, because it is a point cloud format, doesn't lend to attaching objects to it. For example, lights or reflection probes, things like that. And material management is another challenge. So we developed a few tools to help work around some of these, and they're available in Unity's package management system. It's just called the Film and TV Toolbox. So that's available for everyone for free. Now, in the future, when we're looking at how studios are looking to approach these kinds of problems, USD is becoming very, very popular and gaining traction. Around halfway through the Sherman project, the first version of the USD package was released for Unity. And we're actually going to be pushing this further, collaboration with Autodesk and industry partners. I really believe that USD is the future for how a lot of studios are going to organize their assets. Lighting. So lighting in real time is a big challenge for studios moving from traditional workflows. But it's also one of the big advantages. You can actually see your lighting changes. You can iterate very quickly. So there's a few techniques that we're using, but you can see here you can very easily try out ideas. Here are a few of the techniques, so light probes, reflection probes, cascade shadow maps. Essentially all of the lighting ends up being real time. Global illumination was used for sort of the overall world lighting. And then we use a technique called light probes, which samples the light at all of these yellow dot positions. And then dynamic objects like the characters will reflect or represent the lighting properly. A couple of techniques for reflections. Again, this is not using the new ray tracing techniques that are just coming online. In the future, things like reflections hopefully will be easier because ray tracing is there now. But for most cases, you're still kind of faking reflections in real time. So here's a couple of techniques. Again, with lighting, there's a few things, especially when you're trying to figure out how to manage lights across all of your shots. Here, for example, our lighting supervisor created a prefab with a pivot so he can rotate the light around the object. So you can have a light that's actually positioned on the object you're trying to frame and then actually manipulate the light relative. The nice thing is once you have all of these things set up with light probes in the GI, you can do dynamic changes, and then all of your lights are basically dynamic. So this allows you to propagate changes very quickly. Here, he's going from one lighting scenario to another with a couple of clicks. This is also using the nested prefab system as well. So we have a master prefab, and here are a few of the, you can't read it very well, but here are a few of the prefab lights. When you're getting into the final details of your short, having specific lighting for each shot or each camera angle is important. And this is an example of we're just using activation tracks on timeline, where each of the scenes has its own collection of lights and post-processing, and we're just turning them on and off for each camera angle. This allows you to really fine-tune the lighting for each shot. And fur. So there's two challenges that were brought on by the characters. One was water for the sprinkler. The second was fur. So for Baymax, we used Unity's legacy VFX system. We didn't have the new VFX graph. But for this project, we wanted to try and see what the VFX graph would bring to the table. Originally, we thought we were actually going to use Houdini or Maya to simulate a lot of these effects. In the end, we actually didn't go that route, mostly because we didn't know Houdini on our team. So we started out with the VFX graph. So the VFX graph is our new visual node-based effects system. It's kind of a Houdini light in many ways. It's node-based. It allows artists to, again, iterate very quickly. Initially, we thought we would have one water effect for the whole short. In the end, we ended up having more specific solutions to solve specific problems. But in this example, the water's just going wherever the mouse points. This was one of our early tests. The other nice thing about working with the VFX graph and the prefab system is you can have specific prefab setups for an effect and then have per shot changes. So this on the right is the node-based effect system, again, very similar to a Houdini type system. And then on the bottom is individual timeline clips that activate the individual, turn on the effects at various times. This allowed for very quick iteration on the effects. We ended up using the VFX graph for a lot more than we thought originally. So everything, the dirt, the leaves, all of these effects were done with the VFX graph. And you can see here where you can very quickly iterate, try out ideas, experiment, and it's all immediate feedback. This is very powerful when you're working on your ideas. And so fur is the next big one. So it's a very common topic when we talk to studios, is how to, when real-time has certain limitations, fur is one and VFX is the other. So we wanted to see what we could do with fur. Except originally we didn't. We weren't going to do fur. So we were going to do a stylized sort of look like this. Because achieving real-time offline quality fur is a pretty big challenge. Now, when you're looking at hair or fur in any engine or solution, there's 4 key elements that you're looking at. The geometry generation, how do you actually make the fur in the world? Shading or lighting. Dynamics, does it move? Does it have physics on it? And then authoring. How do you create the fur? How do you actually control this from the artistic standpoint? For Sherman, we tackled 2 of those. So the geometry generation and shading, and we've kind of figured out an authoring approach that worked, but it's not ideal. So in the original, we actually started by modeling out the strands of fur. So this was done in Maya, and then we baked it to an SDF, which allowed us to sample the fur to figure out things like specific normals for lighting, strand generation. The nice thing about the SDF is it's effectively unlimited resolution. We also combined the actual asset normals, so the normals on the raccoon, and a screen space version. And we could blend between the two for the final fur implementation. And we also added a second SDF as an overcoat for things like the halo, the fringe fur. But the nice thing is it allowed us a lot of flexibility to achieve the look we were looking for. The actual groom map was done in Mari. So Mari is fantastic. It's kind of a weird interface, but it's great. So we used Mari to paint out the groom maps. In the future, we would love to be able to do authoring like this inside of Unity. That's a project that we're looking at in the future. So some simple stats so again, this is an experimental implementation. We are working with our graphics R&D team to make this an officially supported feature that might land in 2020.1, I hope. We'll see. But that is the goal, where we have the lighting or the shading actually uses the HDRP hair node, so it's actually part of shader graph. So that's supported out of the box. It has your normal Kajia K type shading model. And the work that we're doing now is actually updating this to the latest 19.3 Unity tech stack, and then obviously the collaboration to land it so it's more out of the box for everybody. And then, as I mentioned, better groom tools. Some other tools and features that we created just to help along the way. For rendering, we use the recorder package. So this allows you to configure, that's this green clip here. So if we wanted to render just a segment of the short, we could pick a shot or essentially kind of build our render farm, which was basically 3 PCs I had sitting on my desk. And we would render at 4K and downsample to 1080p, like we were talking about at lunch. So the nice thing with this system is we had a remote in, so anybody could log into one of our PCs and start rendering. And then we would just do the normal render nightly and compile it. The other technique that we developed, which is custom and allows for really advanced motion blur and anti-aliasing, is a super sampling system that we created originally for Baymax. And this is kind of the equivalent of an offline renderer for Unity. We're actually rendering at 960 frames a second. So we're combining 40 frames into a single as samples into the final output. And this gets very, very high quality motion blur and output. So it's not out of the box, the final frames are not real time running at 60 frames a second. But again, that is not our objective. Our objective is to get the highest quality possible out of the engine. In the future, what we're working on right now is a slightly different technique. It's called stochastic accumulation, which is a different type or different approach to rendering that also opens up the possibility to add the same quality to depth of field and other offline rendering use cases. Part of the downside to the super sampling is we couldn't see final quality out of the box. It's hard to see on this projector, but the real-time preview that we would have in the engine wasn't the full quality for rendering. So we created a render window that allowed us to sample at any frame, so we could iterate quickly and test out things like the fur groom maps. And it really improved the iteration time for the artists. So again, some key stats here. No storyboards, straight into 3D. And this is something that the Disney team found was one of the biggest advantages, is getting in and finding your story in 3D is very powerful. A lot of teams tend to work in storyboards for so long, and you don't know if it's actually going to work, because you have to kind of throw that away and start building in 3D. So the quicker you can get into 3D, the better, really. Again, the standard technology that's available in Unity, Timeline, Cinemachine, HD Render Pipeline, and then concept to final frames. Now, there's a very long blog that I wrote about this. It explains all of these things in detail. And in fact, the entire Sherman project is available to download. So you can download the project and look at how it was created. If you check out the Film Solutions page, there's a download link there, and you can check it out yourself. We've also created 3 separate videos that are available on the solutions page that show off some of the techniques that I've been talking about today. So Unity for look development, Unity for lighting and compositing, and Unity for layout and cameras. Of course, this is just one of the many demos. You saw some in the opening note this morning, and we are excited to work with other teams around the world on projects in the future. Thank you very much.